Hello everyone, welcome to my channel Chemistry by ANR. This topic is preparation of alkane. How can alkanes be prepared? We know alkanes are saturated hydrocarbons. So they can be prepared from unsaturated hydrocarbons like alkenes or alkynes by the method of addition reaction. That is hydrogenation. That is what hydrogenation means. Addition of hydrogen. Addition of hydrogen. Of course, in presence of active catalyst, and those active catalysts can be platinum, palladium, nickel, that can produce more surface area to the adsorption of hydrogen. The meaning of the term adsorption means, it is the bringing hydrogen to its surface. That is, you can arrest hydrogen, you can bring hydrogen to the surface of these metals. Adsorption is a surface phenomena. Now, this is ethene. From ethene, you can obtain ethane. Do these corrections in your NCERT book, please. So, ethene, you can obtain ethane. For this, I will say just you can break the bond and add hydrogen on both the sides. So it becomes CH3, CH3. Propene. So this is 1, 2, 3. From this you will get propane. 1, 2, 3. Same manner, add hydrogen on both the sides. So this is propine. So add hydrogen on both the sides. 1 mole. So 2 moles of H2 if you had. Do these corrections again, I repeat. Then you will get what? For 1 mole, you will get CH3, CH double bonded CH2. And when you add another mole of H2, then you will get CH3, CH2, CH3. Of course, in presence of nickel, platinum, palladium. So I already have the product written here. So I'm just writing nickel or platinum or palladium. Here also same thing, nickel or platinum or palladium. You can just mention 2 moles of H2 in one go and you can write the final saturated product, that is propane. Next, from alkyl halide. In general, I will say RX, alkyl halide, where halogen can be chloro or bromo, but not fluoro compounds. It undergoes reduction with zinc and dilute HCl to give alkane. So I can say chloromethane or methyl chloride is the same thing, CH3Cl. This bond, if it breaks in this manner, adding H on both the sides. So this comes out to be HCl. Here is your HCl. And this comes out to be CH4. This is your methane. So this is how you can obtain saturated hydrocarbon. ZnH+. This H plus comes from dilute mineral acid like HCl. This one again, zinc and dilute HCl. In this presence, what you are seeing is reduction of the alkyl halide is taking place. So the main method is a reduction, addition of hydrogen. Though it is not a double bond or a triple bond, it's all sigma bond. Then also the bond breaks in this manner and H gets added up. So C2H5 gives you C2H6, that is ethane. Write it in this manner, CH3, CH3. And here you can see HCl. So this H2 can be written in this manner, H and H. Then only you can remember, it will help you to remember all these things. Now 1-chloropropane. So this is 1, 2, 3, 1 position there is chloro. And you break this bond in this manner, again add H and H. So you get a propane here with HCl, corrected HCl. Next, 2 moles of alkyl halide. 2 moles of alkyl halide on treatment with sodium dry ether gives what? Gives higher alkane, means it gives symmetrical alkanes. It gives symmetrical alkanes containing even number of carbon atoms. Containing even number of carbon atoms. Here we can see containing even number of carbon atoms. Now the question arises, why? If we take 2 moles of the same alkyl halide, you can just cut out this part and imagine that it is forming 2 moles of NaBr. Correct it. 2 moles of NaBr it is forming. And it is forming, combining and forming CH3. Correct it. It is ethane. So it is ethane which is forming CH3. If you write it in general, write it in this manner: 1 mole of Rx plus 2 moles of sodium plus another mole of Rx. Write it in this manner: another mole of Rx. Okay, so you can just write dry ether medium. So this is your dry ether medium, and cut out this part. 2 NaX can be cut out, and then you can write, you can join this R to this R, and you will get symmetrical alkane RR plus 2 moles of NaX. Remember that this NaX is insoluble in dry ether, and it gives you a precipitate for which you can separate this NaX and get good yield of symmetrical alkane RR. Now, why I am telling even number of carbon atoms? 2 moles of this Rx. If I say 2 moles, then if this R contains n number of carbon atoms, then the final product will contain 2n number of carbon atoms, which is always an even number. Now, if I want to prepare alkanes containing odd number of carbon atom, then what will happen? I have to take a mixture of compound. Like here, what will happen if 2 different alkyl halides are taken? Yes, what will happen? So let us see. Rx with that of 2 moles of sodium with that of R-X. What will happen? See, 2 moles of alkyl halide Rx can give you RR. 2 moles of R-X can give you R- and R-. And if 1 mole of Rx and 1 mole of R-X combine, it can give you RR-. So you will actually get a mixture of product. So you're not getting one product, you will get a mixture of product, not with a good yield. So Wurtz reaction is not giving you the reaction where you can start with 2 different types of alkyl halides. Wurtz reaction is always giving you 2 moles of same alkyl halide. It is our assumption that if we take 2 different alkyl halides, what will happen? That will happen that we are getting a mixture of alkane. Now, from carboxylic acid, sodium or potassium salt of carboxylic acid, so we can say RCOONA or RCOOK. From there, by the method of decarboxylation, means removal of CO2, and this CO2 combines with NaOH to give you Na2CO3. Now, the mixture of sodium hydroxide and calcium oxide, that is sodium hydroxide and quicklime, is known as soda lime. When you take this, decarboxylation forms, that is, you get an alkane containing 1 carbon less than the carboxylic acid. This is very essential. If I contain it, if I start with n number of carbon atoms, I will get n minus 1 number of carbon atoms in the product. Obviously, because the carbon is going out as CO2 combining with NaOH forming Na2CO3. So your number of carbon atom decreases. Number of carbon atom is decreasing over here. Now next again, see, sodium salt of which acid will be needed for the preparation of propane. So you see how many carbon atoms are there in propane? There are 3 carbon atoms, and then the starting should have 3 plus 1 number of carbon atoms. So that's why it is actually this 1, 2, 3 and 4, and this will be increased in COO minus. So we can start with this. So what you will do is just remove CO2 and imagine that you are giving one H over here to find the structure of the final product, and this becomes your final product, CH3, CH2, CH2, and you have given one H, so it is CH3, CH2, CH3. So this is how you will do it. Kolbe's electrolysis method. So Kolbe's reaction is something else, and Kolbe's electrolysis is something else. In electrolysis method, an aqueous solution of sodium or potassium salt of carboxylic acid is used. And the alkane that is produced contains even number of carbon atoms. Okay, and the alkane is obtained at anode. Alkane is obtained at anode, and that is essential to see how it is obtained. Sodium acetate is taken 2 moles of H2O, electrolysis. It is electrolysis, and you see CH3, 2 moles you are getting, plus 2 CO2 plus H2 plus 2 NaOH. So in Kolbe's electrolytic method, what did we see? That 2 moles of sodium acetate if we are taking, then it forms 2 moles of, it forms CH3 from this part. It gives out CO2 and it gives out H2. So at anode you are getting 2 moles of methyl free radical and you are getting 2 moles of CO2. CO2 is obtained at anode and at cathode H2 is obtained. Why can't methane be prepared? Because minimum you need 2 carbon atoms to start with. 1 carbon atom gets eliminated as CO2. So the minimum requirement in the product is also ethane. So bye all of you. See you in the next session with properties of alkanes.